H10 is an interesting analysis where we're going to design a circuit as opposed to be given the values of the resistors. We're going to calculate the values of the resistors. Did we do something like this once before? Yeah, I think so, with a base bias circuit. We're going to do the same thing here. So the circuit we're talking about is the same voltage divider. R1, R2 is my voltage divider circuit. The values are not given. Okay, what's given is VCC 12 volts. Connect the transistor. RC to the collector, RE to the emitter. So that's my standard voltage divider circuit. NPN. RC is not given, RE is not given, R1, R2 are not given. What's given are the parameters. So this is similar to the case where you're working for a company and a client comes to you and says, I want you guys to design a circuit for me, okay, given the big picture. I've got a supply voltage of 12 volts, my maximum current is 12 milliamps, find a circuit, design a circuit for me, okay? So that's what we're given. The voltage is 12, the current saturation, which is the maximum current, is 12 milliamps. IC sat, 12 milliamps. And HFE. HFE is given to be 100. We're going to change it to something more along the line of what we are finding out in the lab. How much is my HFE that we've been working with in the lab?
220.
About 200? Let's put 200. HFE of 200. That's it. So that's the information that's given to me. Let's find out the values of R1, R2, RC, and RE. So the first thing I'm going to do is show my load line and the Q point on it. So draw the straight line for the load line. The transistor works along the load line. X-axis, VCE. Y-axis, IC. VCE is the voltage from the collector to the emitter. IC is the current flowing into the collector to emitter point of the transistor. Okay, these are the two most critical values of a transistor. So, design this circuit for midpoint bias. What is this value here? Is that cut off?
Yep.
So how much is that? 12 volts. When the transistor acts like an open, okay, current is 0, voltage is 12, same as supply. So that's cut off. When the transistor is acting like a closed switch, maximum current flows, which happens to be saturation. Saturation is the same thing as maximum, 12 milliamps. So those are my two endpoints. And somewhere along that line, my transistor is going to operate. I'm told midpoint bias. So right in the middle. How much for VCE? 6. How much for IC? 6. You see where I'm getting those numbers? Midpoint. Okay, so given the Q point, I'm going to be working backwards. I'm going to find out RC, RE, R1, R2. So, what circuit designers do, what engineers do, is they work with experience, with years of experience, years of designing circuits. And so they come up with rules of thumb, okay? And we have a couple of rules of thumb that we're going to be working with. So at the top of the page, we've got these rules of thumb for this circuit mentioned. The first one says, let VE be 10% of VCC. VE, which is right here, E to ground. This voltage is going to be 10% of VCC. Where did we come up with this rule? Just with practice, with experience, okay? With years of designing these kind of circuits. So, 10% of VCC, 0.1 times 12. How much? 1.2? The idea is that these two rules of thumb apply for stiff circuits. So write the note stiff circuit beside the rule of thumb. Where it says rule of thumb, on the right side indicate for stiff circuits. These rules of thumb apply for stiff circuits. Okay. So, on your notes, the first one is cutoff. VCC, how much? 12. Saturation, how much? 12 milliamps. VE, 1.2 volts. Next, now that I know VE, I'm going to find RE. My first of the four resistors, RE. For RE, I'm going to use Ohm's law. VE over IE. Anybody see that? There's VE here, voltage at the emitter to ground, and divided by the current, IE. So, can I say that IE also is approximately equal to IC? That's always the case in a transistor. Okay? And which IC am I talking about? 12 milliamps or 6 milliamps? It's the 6 milliamps. So let's put a Q beside it. So that's going to be 1.2 volts divided by 6 milliamps. So what's 1.2 volts divided by 6 milliamps? 200 ohms. First of my four resistors has been found. Okay? So this is 200 ohms. Now,